only mode.
Hello everyone, good afternoon. Nice to see you too. So I hope you all had a nice week off. Did you enjoy or did you have school? School. Oh, okay. Okay, so I think when ma'am had taken this chapter, she had given you practice question ones as homework, right? School was there, yes. Okay, so hardly like 7, 8 of you had submitted that homework. The rest of you, have you done it or and not submitted, or have you not done it? So I want to know from where I should start. Yeah, okay, Netri, you have submitted. That's good. Yeah, like I said, only around 7, 8 people have submitted it. You have done it and submitted. Okay, so they were theory-based questions. Okay, is that Shakti? Okay, Shakti says I have done it, but I don't know how to submit it. Okay, there's a link which was given long back, the homework and notes link. What I'll do is I'll resend it after the class. Okay, I'll do that. Uh, is this important for me to attend? Okay, I'm going to cover the different questions which are there in the workbook today, like help you out. And I want you all to do the remaining questions on your own. So, yeah, if you have not attended the session, maybe this will be helpful. I'm not doing a recap of the chapter as such, I'm just going to go through the questions. So, maybe you'll get a hang of it. Okay. Okay, I think everyone's here. Let's start. We'll do that. Okay. So, is my screen visible? Hello, good afternoon. Yes, it's visible. Okay. So, what I'll do is one or two questions from theory based and give reasons which I feel are tricky. I'll just go through them. Okay. So, let's keep this a bit sort of interactive. Hello. Yes, hello. All those who joined now, I have not started anything. Okay. Yeah. So I was saying that when you had done this chapter, you were given practice questions as homework. I think that would cover theory-based questions, give reasons, and what happens when, right? So, and only 7, 8 of you had submitted it. So the rest of you, I don't know if you did it and did not submit, or you did not get it. So I'll quickly go through 2, 3 questions which I feel are a bit tricky, right? So it'll help you all. Okay, but in case you have any questions in a particular in between, or you have pinpointed questions which you have doubts in, you can let me know. Okay. Yeah. So theory based questions. Yeah, and I want you to write down the answers to the questions I am doing today, right now, even if they seem easy. Okay. Okay. So theory based questions. What is the full form of CNG? That's easy. Then this is also theory based. Mention two ways to liquefy atmospheric gases, again theory based. Okay, so I'll directly go to the seventh question, which is a bit interesting. Give reasons for the following. I said 0 degree Celsius appears colder in the mouth than water at 0 degree Celsius. Can anybody tell me the answer to this? You can either raise your hand or you can type it, whichever is convenient. If you find typing is too much, you can just raise your hand. I'll, you can answer. Okay, yes, Dhruv and Puneet have answered. What about the rest of you? Okay, so Molly has yes, Alina, that's right. Okay, Molly, you can tell me your answer. Hi. Okay. Anybody else? I got only three answers. Give reasons for the following. Ice at 0 degrees Celsius appears colder in the mouth than water at 0 degrees Celsius. You can either type your answer or you can raise your hand, whichever is easier. Yes, Neki, you would like to answer?
Yes, ma'am.
Yes, tell me.
Can you hear me?
Yes.
Ice at 0 degree, sorry, is more cooler because water has gone through the change of in and uh, due the hidden heat is not seen, but sorry, there's no temperature change, but it has gone through the change of intermolecular force of attraction, and then it has more heat than ice, latent
Okay,
heat.
you are right. The just the last part is correct. That latent heat. It has gone through intermolecular force of
Yeah.
attraction. No, that's not right. Okay, yeah, it's correct. The latent heat part is right. So, okay, I'll tell the correct answer. Okay, somebody is typing. Latent heat is absorbed greater than the. Yes, Molly, you're right. So, those of you who have answered, you are right. It's because of the latent heat and ice. So, what is the reason? Ice is also at 0 degree and water is at 0 degree. If you recollect, 0 degree is the melting point for. Okay, Mansi has given me the answer. Yes, Mansi. Yeah, that's quite right. That's pretty close. Okay, Puneet, you would like to answer?
Hello.
Hello. Hi,
Hello,
Puneet.
ma'am.
Yes.
The melting point of ice is 0 degrees Celsius. Also, during this time, at a specific time, there is no temperature change because at this time ice change converts into liquid, that is water. So there's extra energy present in water in the form of latent heat of fusion.
Okay, extra
So,
energy
like
present
as
in the
water has
water.
extra energy,
Water or ice?
yeah, water.
Water. Okay.
So as there's no energy present in ice, as there's less energy present in ice as compared to water, it feels much colder when put in mouth.
Okay. Yeah, that's right. Yeah, he's explained it using water. So Puneet explained it using water. Yeah, right. So basically, what you can say is that since 0 degree is the melting point or the point where water changes to ice, so it will have more heat compared to ice, and ice will appear cold, right? Due to the latent heat of
Ma'am,
fusion.
for those who have written, ma'am,
Yes, tell me.
um, for those who had done the practice questions before, do we have to write these again? What you are solving?
No, it's okay. I'm just going to pick up 2-3 questions from here. So if you don't write it, it's okay.
Okay, ma'am.
Okay, and the next one, what about the next one? Doctor's advice. Okay, wait, somebody just joined in and has a question. Arav, yes, hi, you joined right now. So I'm going to take up questions from the workbook of this chapter. Okay, and when ma'am had done this chapter, she had given you practice questions as homework, right? So, but only few of you had submitted it. So I'm just picking up 2-3 which are difficult and seeing if you all are able to solve. Then I'll move on to level 1. Okay, Mansi has answered. When a person, yes, Puneet, yes, Mansi. Okay. So the second one, doctors advise to put strips of wet cloth on the forehead of a person uh having high temperature. So basically, okay. Yes, Netri. Yeah, you're right. So what happens is when you place a wet cloth on the forehead, the heat is absorbed by the wet cloth, and the water evaporates because of the heat. So that will lead to a cooling effect uh, in the person's body, right? So just two important points. Yeah, heat is absorbed by the cloth and the water evaporates, which leads to cooling effect, right? Okay. So you got this question. Anybody with any doubt, or shall I just go ahead? Okay. No? Okay. Nice. Okay, so then the next question is, what are the differences between solid, liquid, and gases? It's, I think, direct, right? Explain the term density. Okay, that's also direct. Fill in the blanks, direct. Okay, we'll move on to give reasons then. So, all those of you who had done this homework and submitted it, great. But the ones who have not, please make sure you're going to solve all these questions today and submit it. Okay? All the theory based questions, give reason questions, what happens when questions. Okay? After the class. Okay, give reasons. Let me see which one should I pick up. Mm, okay, this one. Why does a palm feel cold? You. When will we get to know the report of our submission? Soon. Okay. First we'll just solve these questions. Okay, I think these are pretty easy, isn't it? Why don't you all try? Okay, yeah, this one's a nice one. Why a gas cylinder cannot be half filled? Are you all able to see my screen? Netri, can you check your connection once? Maybe. You can't see my screen. Okay. How about now? Is it visible now? It's lagging. Okay. Yeah, I'm on the give reason page itself. Okay, I don't know why it is lagging though. Let me see. Now can you see the screen? Maybe some problem with my application. No? No? Okay, what I'll do is I'll just try to share my screen again. Oh, somebody's saying yes, somebody's saying no. Okay, check now. Now I have uh now it's visible. Okay, maybe it's that application is not accepting, but it's lagging. Okay, yeah, I'm on one page itself. Now, yes. Okay, most of you can see it. Nice. Okay, so I was talking about give reasons. So pretty Most of them seem pretty direct to me, like which you can do yourself. So I'd like you to try them on your own. In case you have doubts, you can, ask me later. Okay, you can see the screen, right? Nice. Okay, I want you to tell me the answer to this question, the 10th one. Why a gas cylinder cannot be half filled? Anybody? You can raise your hand or you can type it in. Yeah, the question is why a gas cylinder cannot be half filled. Why we cannot fill any containers with, half the amount of gas. If it's difficult to type, you can just raise your hand. It's not an issue. Okay, I see Dhruv and Raghav have raised their hands. Yes, Dhruv.
Yeah, ma'am. Can you hear me?
Yes.
Yeah, we can't fill a gas cylinder half because intermolecular space present between the gases a lot. So no matter how much we fill, the gas will spread out in the whole container.
Okay, yeah, awesome. That's right. Okay, I'm getting more answers. Gases don't have volume. Are you sure about that? Somebody has said gases don't have volume because gas occupies all the places. Yes, Elena. Yes, Anirban. Yes, Netri. Okay, Puneet, you have a doubt in the next one. So what I'll do this question, then we'll take up the next one. Okay. Okay, Muskan also has the answer. Yes. So basically, I think most of you got this, right? Raghav also has answered. Yes. Okay, so basically, why can a gas cylinder not be half filled is Molly has also answered a gas cylinder cannot be half filled. Yes. So they have less force of attraction. Yes. The intermolecular forces of attraction are not that strong. And what happens is when you fill a gas in any cylinder, the molecules rush to occupy the entire space. That's it. That's the reason it cannot be half filled. So in whatever container you put, it's going to occupy all the space. They will, uh, you know, rush to occupy the entire empty space. Okay, so yeah, Puneet has a question in the 11th one. Let's see what is the 11th one. Okay, why do gases exert more pressure on the walls of the container than solids? Can anybody answer this? Okay, the next question. Yeah, I'm talking about the next question, the 11th one. Why do gases exert more pressure on the walls of container than the solids? Puneet has a doubt in this question, so can anybody answer? Can anybody clear this doubt? Because the movement of the particles. Okay, Vansh, I think Vansh is ready to answer. Let me check. Yes, Vansh.
Ma'am, I think it's because of the kinetic energy and the intermolecular movement that the gas particles possess.
Okay, yeah, that's quite right. So yeah, I'm getting more answers here also. So because gas molecules tend to roam around freely and try to escape. Okay, gases exert than solids because there's more kinetic energy in the gases. So basically, Puneet, like this is connected to the previous question that gases rush to occupy the space of a container, right? So they are going to keep hitting the walls. Every time they hit a wall, they are exerting some amount of energy, right? So that's why. You you got it? Okay, nice. Okay, good. Because there is, yeah. What other question? Why does the temperature remain constant during sublimation? Is let me know quickly. So this you can just answer orally. Don't write. When I take up level 1, you start writing. Okay. Ritvik, do you want to answer this question? Hi, Ritvik.
I was actually asking for the last one.
Oh, the last one. Okay.
Can we just say it's a fluid because a fluid is something which flows?
Where, like, for what this question
There-
will be?
There's a container one that it presses the wall. Can we say it's a fluid because it is a fluid? It flows. So
No, no. So the question is, why do gases exert more pressure, right? So you cannot call it a fluid. They are asking you why gases. So the gas molecules will continuously bombard the walls, and each time they bombard the walls, they are going to exert some kind of energy, right?
okay,
That is
okay,
why. Whereas the solids are compactly packed, they don't tend to, hit the walls much, or they don't move around that much. Okay, so
okay.
that's the answer. Okay, so let's see. Can you repeat the question? I am asking, the question is here. The 13th one. Why the temperature remains constant during sublimation? My voice is echoing. Sorry. I think there is some connection issue here. I'm not able to figure it out what it is. So, I don't know. Hopefully, it will get better. Okay, yes, Tanisha has answered. Anirban. Okay, Anirban is talking about the previous question. Yeah, latent heat. Yes. So Puneet says latent heat of vaporization. Okay. Raghav, what about you? Yes, I have unmuted you, Raghav. You can tell me.
Ma'am, basically, during sublimation, no excess heat would be applied. So, no exterior heat should be applied, and it can automatically uh, convert into a gas with the help of latent heat of vaporization.
Okay, so here the question is, why is the temperature constant?
Because of latent heat. So, the heat required to change a body into another state is called latent heat, the hidden heat basically,
Mm-hmm.
and no exterior heat would have to be applied. Without that, we can convert it.
No, the
That's why it
first part,
remains constant.
yeah, the latent heat part is right, but the second part is not right. Like they are not asking you, is external heat applied or not. So in this case, the correct way of putting it would be whatever heat is emitted, okay, is used up in changing the phase. Hence, the temperature is not increased. So whatever heat is emitted by the solid, or is given out by the solid, is completely used up in converting into gas phase. Okay, hence the temperature will be the same. It's not used up in increasing the temperature. If it was not used up, then the temperature would increase. Yes, Netri is right. Muskan is right. Yes. So basically, whatever heat is given out, so you can just take it down if anybody has a doubt. Okay, so whatever heat is given out by the solid is used up in changing the phase. Of changing the phase in sublimation is solid to gas, right? So it's used up in that phase change. Hence, there is no increase in the temperature. Got it? What is acetone? Okay, Ritvik, acetone is a volatile chemical. So volatile is one which evaporates very quickly. If you just keep it open, it evaporates. It has a very low boiling point, basically. Okay, since somebody has a doubt in the next one, can you tell me why do liquids like ether and acetone are kept in cool places? Acetone is actually a nail paint remover, right? That liquid is acetone. Yes, yes, Aditya Rani. Yes, Puneet. Yeah, they have low boiling temperature. So ether is also one such solvent, you can say. It's an industrial solvent. So even chloroform also comes under this category, same category. Yeah. So if they ask you questions like some solvents like that, like chloroform, ether, acetone, uh, they evaporate easily because they have boiling points, almost the same as room temperature, something like that you can say, quite close to room temperature. So the minute you just expose them to the environment, they will evaporate. Yes, so yeah, we store them in cool places so that they don't evaporate, so that we don't lose it. Right? In fact, they're even kept in dark colored bottles. Right? Yeah. So I think you can use the same answer for this fifth give reason. Why does our palm feel very cold when we put acetone or petrol or perfume on it? Okay, it's the same thing. That they evaporate very easily. So what do? They use up the heat energy from our palms in evaporating, and hence since there has been a heat transfer from the palm to the acetone and it evaporates, so the palm is cold, right? So yeah, okay, highly volatile. Yes, Muskan, you're right. Somebody is asking why do they give off cooling effect? Yeah, so I just answered that, right? Why do they give off cooling effect? So what happens is they have no, Anirban, no, I don't think kinetic energy is, there's nothing related to kinetic energy in this answer. The answer will be they have low boiling point. First of all, they have low boiling point, hence they evaporate easily, right? So first point, low boiling point, hence they evaporate easily. Secondly, when you place them on the palm, so whatever heat our palm is emitting, they use that, the acetone molecules or ether molecules or whatever that solvent molecule will use that to evaporate. And since it's using that to evaporate, it's taking heat from your palm, so hence your palm will feel cold because there is heat loss. Okay, no connection to kinetic energy or anything here. Molly, you're halfway right. They don't take up heat from the atmosphere. They take up the heat from your palm. Okay, they take up the heat from the palm and they evaporate. So you will be left with, even if they ask you if the surface is cool or why are they kept in cool, both these questions. So question which was it? Sorry. Yeah, the give reason 14th one and the fifth give reason have the similar answer. Okay, interconnected, quite similar answers. Okay, and yeah, so why does the temperature of a substance remain constant during melting point or boiling point is similar to the sublimation one, right? Because of latent heat. Explain it properly. In these give reason type questions, you must ensure that you are writing all the keywords. Like if you need to mention that low boiling point, then they are taking up heat from a place. You mention all those things. Yes, Vasudha, because of latent heat. So yeah, this is a similar question. The rest are easy. Okay, can you tell me the last give reason? Why does honey diffuse in water at a slower rate than ink? So what is diffusion? Diffusion is the movement of molecules from a region of higher concentration to lower concentration. right? So anybody? Okay, yes, Dhruv, and there's one more point. So here there are two points, main things which because of which honey diffuses slowly. Yes, Neki. And what more? What else? Elena, no, I wouldn't say that's quite right. Yes, Puneet. Uh, Atharva, no, not more volume, some other term. Uh, Netri, if it's lighter than ink, then no, you're contradicting your own point. Vasudha, no, this is not about water. This is a point. This is a property of honey. So here two properties of honey are, important. Try. Okay, I'll let you all try more. Yes, Anirban, that's right. That's one. And one more point. Ritvik, no. Okay, so see the concept of kinetic energy comes into play only when the molecules are, moving or are bombarding a wall or are bombarding something. Yes, Vasudha, you're right. That's one point. And one more. So there is nothing about kinetic energy in this question. Yes, Aditya Rani. Yes. Abhishek, yeah, can you highlight more on it? So, okay, basically you are all like quite there. So, yes, one of the point is honey has more density compared to ink. It's denser than ink. Second point is it's more viscous. So, basically, viscosity is the term given to something which is more thick, something which doesn't flow easily. If you say in simple words, the thickness or the fact that it doesn't flow easily, those liquids are known as viscous liquids. One of them is honey, the other is mercury. See, mercury will not flow. If you've ever seen, maybe by chance broken a thermometer, you would have seen. Okay, so like honey is sticky, right? It doesn't flow, it just sticks to your hand if you touch it, or it sticks to the spoon. So those two reasons. Ensure that you write both of them. Okay, first one is density. Honey is more dense than ink, so it takes more time. And second, it's more viscous. Yeah, even if you add honey to water, you need to stir it a lot, right? Yes, Muskan. Okay, so make. I hope you all have made a note of this. So okay, we'll go ahead. What happens when? Okay, yeah, the first one. I think this is the only crucial one here. What happens to the boiling point of a liquid when the atmospheric pressure decreases? Anybody? Okay. The boiling point increases. Are you sure? Increases. Ah, increases. Okay, how many of you say increases? Hmm. Okay. Neki and who's the other person? Okay, oh, Vasudha has some question. Once I broke a thermometer. Yeah, okay, Vasudha, yes. So, yes, I have done the same thing. Even I broke a thermometer once. Yes, you should not touch mercury. You should not step on it. It's dangerous because it's carcinogenic. It's a cancer causing toxin. That's why it is dangerous. Okay. Oh, and Aditya Rane Neki, the boiling point will not increase, it will decrease. So, okay, this is based on the very simple concept. Uh, yes, Muskan, you're right. Netri, oh no, okay. So, this is just based on the definition of boiling point. What is the boiling point? The boiling point is basically the temperature, the point at which the pressure of the vapor pressure is equal to the atmospheric pressure. At that time, the liquid will get converted to vapor. Okay, so if you are saying that vapor pressure is the point at which vapor pressure equals to atmospheric pressure, if the atmospheric pressure goes down, automatically it will take lesser vapor pressure to convert to vapor. Am I making sense, or am I saying gibberish? Okay, making sense. Nice. Okay, one of you only said that. What I'll do is I'll write it here. Okay. So here, just remember one thing. Boiling point, okay, is the point where vapor pressure is equal to atmospheric pressure. Okay, it's at this. This is basically boiling point in simple terms. Okay, when this happens, when the vapor pressure is equal to atmospheric pressure, the liquid changes to vapor. Right. So now what they are saying that we brought down the atmospheric pressure. So which means if this is down, which means amount of vapor pressure needed to equal to this thing will be low, will also come down. Correct? If the atmospheric pressure itself is low, so the amount of vapor pressure required to get to this will also be low. Hence the boiling point decrease. Okay. Uh, is this clear? Got it? Got it? Uh, yes. Puneet, yeah, you're right. Got it. Okay. So remember this concept. It will be easier because this is connected to one more question, which they ask why pressure cookers are used at high altitudes. Why is it difficult to cook food at high altitudes? All these questions have the same answer. Okay, we are going to take that question once later. So that time I want all of you to answer it. Okay, Netri has a doubt in a question. Let me check. What is the question? Huh? Netri, C part, can you tell me which question exactly you have a doubt in? I'm not able to understand. Netri, hi, are you there? Can you tell me which question you have a doubt in? Question 4. Okay, so which part of question 4? What does question 4 says? You are provided with a mixture of naphthalene and ammonium chloride. Okay, suggest an activity to separate them with a well-labeled diagram. Can you see my screen? The screen is there itself. Okay, you want to see the whiteboard, this part. Okay. Okay, so Netri, what is your doubt? You want to know the experiment? How to do, what is the experiment? Is that what you're asking? Okay, yes, the experiment. Okay, so this is a quite direct question. So I'll just let me just tell you how to do it. Okay, so in this, the experiment is that you take a conical flask, right? And in this flask, you add naphthalene. Okay. Oh. you add naphthalene, and you add ammonium chloride. Right? You take a mixture of this in this flask and you heat it. Supply heat. So as you know, naphthalene is a volatile substance, or it is a sublimable solid. Yeah, and when you heat this, you plug it with a cotton plug. So the experiment goes like this: take a conical flask, add naphthalene and ammonium chloride in it, and heat it. So when you heat it, the naphthalene vapors will rise up. This is the naphthalene vapor. Okay, I'll just label it here. Naphthalene vapor. It will rise up and it will start condensing here, and it will form the condensate here like this on the flask, on the neck of the flask. And you will still find ammonium chloride here. So that's how you can separate it. Okay. Okay, got it? Nice. Okay. Any other questions? Or I'll move on to level 1. This is there, I think, in your chapter notes, this experiment. No doubt. Nice. Okay. So we'll start level 1. Now you can start writing. Okay, because you have not done level 1, right? Okay, so we'll go slowly. Yeah, I want all of you to write it now. So after class, you're going to submit it. And I'm going to give you a few more extra questions as homework. So the ones who have not submitted the previous one, you have extra work this time. That you have to submit till what happens when, and then whatever I'm doing now. Okay, and a few more questions which I'll give you. They're easy, so please, I just want you to mention the key points. Make sure you do that. Okay, first one, it's easy. Which of the following are matter? Chalk, air, love, smell, hate, almonds, thought, cold drink, smell of perfume. So quickly write it down in your books. Which do you think are matter? I'm going to just, ask one of you to give me the answer then. Which of the following are matter? Chalk, air, love, smell, hate, almonds, thought, cold drink, and smell of perfume. Okay, so I think Raghav is done. So Raghav, yes, I'm going to let me unmute you. Where are you? Okay, yes, Raghav. Tell me.
Should I tell all?
No, just tell me which are matter.
Chair, air, hate. Oh no, sorry. Chair, air, almonds, cold. No, wait, sorry. Again. Chair, air, cold drink, and smell of perfume. Almonds.
Chair, air, almonds, and cold drinks. Yes.
And
You,
smell of
Vasudha.
perfume.
Smell of perfume, will that be matter? Does that occupy
Yes.
space and have mass? Okay, let me check. Chair, air, smell of perfume. Okay, chair, air, smell of perfume. Almonds and cold drink will be matter. Okay, fair enough. Yeah. Okay, so you'll have answering. Which of the following are matter? Okay, so the 2 points you need to consider here: what occupies space and has mass. You have a doubt. Yes, Abhi.
Yes, ma'am.
Yes, tell me, what is your doubt?
If smell of perfume is a matter, then smell is also a matter, right?
Yes. I'm not sure about this. It should be because smell is matter because due to some volatile substances in air which have. Okay, yeah, justifiable. So yes, so it will be chair, smell, almonds, cold drink, and smell of perfume. Smelling, they are saying smell. Okay, so here they are saying smelling is matter because of some substances which are there in the air, because of volatile substances which are there in the air which occupy some space. So that's what they are saying. That's why they are considering smell as matter. Yes, even I had a doubt that is smell matter. So it says here it is matter because of the presence of some volatile in substances in air which have space and occupy mass. Okay, next one. Write it down. I hope you all are writing it down. So the next one. Diver is able to cut through water in a swimming pool. Which property of matter does this observation show? Netri, I'm not sure if that's right. Yeah, Puneet, you're right. Yes, Atharva. A simple property. So a diver is able to cut through water. I hope you got the question. Alina, yes. Nikki, yes. You know what they're trying to say, cut through water as in, right? That when you swim, or okay, when you able to dive, you're breaking the surface of the water and entering inside. Yes, Natri, yes, Dhruv, yeah, you got it now. Mansi, yes. Okay, so yeah, I think it's pretty straightforward here, right? This is the property that uh, matter has space, right? Gaps. Yeah. Yes, Ranveer, you're right. Okay, easy. Aditya, if you have not submitted the previous one, you should submit it. Vasudha, where is your answer? Let me see. Vasudha, it won't be weak intermolecular space. It's basically water has intermolecular space. That's why we can cut through it. Okay. Yeah, who was asking me, do you have to submit both the homework? Yes, if you have not submitted the previous one, you have to submit both. So the answer is simple, intermolecular space, right? Yeah, don't just write intermolecular space as it is. Write the complete sentence, right? Why intermolecular space? How does it show its intermolecular space? Write that. Okay, so tabulate differences in characteristics of states of matter. This I think you can do on your own. Okay, Aditya, you were not there, so you can refer to the recording. Okay, you'll get a hang of it. Okay, this next question, the fourth one, seems straightforward. You can, answer it. Tabulate the differences in characteristics of states of matter is a direct question, right? And other things are just simple plain terms. Convert the following to Celsius scale. How do you convert? What is the formula to convert from Kelvin to Celsius? Correct, Netri. Okay, Arushi, acha, all of you are worried about what to be submitted. For now, just solve whatever I'm asking you to solve. Okay, don't worry about that. I'll tell you at the end of the class. So don't take tension. Yes, Atharva. Ritvik, are you sure that that value has to be used? Acha, no worries, Raghav. Now you can do those questions. It's okay. Okay, so quickly solve it in your notebooks and tell me the answer. I'll tell you from Celsius. This is from Kelvin to Celsius, so you'll subtract minus 273, or to be precise, 273.15. Anything is fine. Ryan, you add when you're converting from Celsius to Kelvin. When you're doing it the other way around, you'll subtract. Okay, so Atharva is giving me the answer. Let me check. Atharva, the first part, just check once. Second part is correct. Vasudha, yes. Ritvik, check the first part once. 25, Netri, check calculation. Yes, Celsius to Kelvin you add 273. Kelvin to Celsius you subtract. Neki. Atharva, yes. Now you're right. Aditya, are you sure? Check. Okay, that's Raghav. Raghav, check once. Ryan, okay, so here they are telling you convert from Kelvin to Celsius. How is the unit Kelvin again? Tanisha, first part is right. Check the second part. Ryan, how is it Kelvin? Puneet, yes. Raghav, yes. Neki, okay. Netri, if you add, right? If you're going to add 273, you're going to get a large number, right? This says convert from Kelvin to Celsius. 300 Kelvin to Celsius. Always remember Celsius is usually lower, right? Way lower than Kelvin. Kelvin starts at 273, Celsius starts at 0. So how will you remember that whether you have to add or subtract? Celsius always will be in lower ranges, right? When you get 573 and all, it will be Kelvin. So if you have to subtract 273 to get back Celsius. 470. Tanisha, why are you using 470 minus 273? It's 573 minus 273, right? It's simple calculation. Okay, who is getting stuck? Where I don't know. Okay, I'll just do it here. I'll quickly do it here. Okay, so it's given Kelvin to Celsius, right? So Kelvin to Celsius is what? It will be C is equal to K minus 273. The first part is C is equal to what is the temperature 300, right? So it will be K is given as 300 minus 273, which is equal to 27 degrees Celsius. Ensure that you're writing degrees Celsius and not Kelvin again. Second one, again, C is what? 573 minus 273, which will give you 300 degrees Celsius. Okay, I hope all your doubts are resolved. Oh, you're looking at the wrong question. No worries. Puneet, you are asking me which question is this? 1.1.6. What is the physical? I'll get to this question, right? I'll help you out with each of them. Okay, got it, right? Okay, next one. What is the physical state of water at 250 degrees Celsius and 100 degrees Celsius? How will you answer this question? Is look at the range and see whether if there is a melting point or boiling point given somewhere, but are gases. One is plasma. Huh? Netri, it's asking the physical state of water. So it's just if they ask you physical state, you just have to answer as gas, liquid, or solid. No, don't answer with plasma or Bose-Einstein. Atharva says one is vapor. Yes. Okay. So one is vapor. Obviously, the boiling point of water is 100 degrees Celsius. Right? It's way above the boiling point, so it will be vapor. Correct. Second one at 100 degrees Celsius. This is a trick question. Okay, Vasudha, first part is correct. Second part is halfway correct. So yes, the trick part is at 100 degrees Celsius. Okay, at 100 degrees Celsius, which is the boiling point. Okay, you cannot say half vapor exactly. You can say, because we cannot quantify how much amount has been converted to vapor and how much is in liquid. So you just say a mixture. So the answer for the second part will be, it is a mixture of vapor and liquid, or mixture of gas and liquid. Yes, Mansi. Water is boiling at 100 degrees Celsius. It undergoes change of state. Okay, am I not audible? Puneet, check your connection once, maybe. You are okay. Puneet, check your connection once, maybe some issue. Okay, now. Okay, so what did I say? What are you going to write for 100 degree? I hope you all are writing all this down, huh? You have to submit it. So write it down. At 100 degree, it will be a mix of liquid and vapor. Why is that? Because 100 degree is the boiling point, right? Okay, easy. Okay, no doubt, right? Okay, next question. Convert the following to Celsius. We just did one question, so do this on your own. And the next one. So it's Celsius to Kelvin. So now add, right? So do these questions on your own. And yeah, you can just write it in your books. No need to write it here, but solve it in your book. Okay, all this. So this conversions is easy, do it on your own. And the last one, arrange the following substances in increasing order of forces of attraction between the particles. This is also easy. You all write it, I'll just pick one of you to give me the answer. So write your answers. I want you to write 3. Yeah, you need to do it in your notebook. So do it in your notebook. Then I'm going to ask you to give me the answer for the last one. Arrange the following substances in increasing order of force of attraction between the particles. Okay, Tanisha, Puneet, Naitri and Abir have answered. Increasing order of force of attraction. Abir, the sign won't be that. The sign will be the other way around. So how do you write it? Okay. Anybody who is having a doubt with the sign, I'll just show you how do you write it. So what is the, it says, so your options are oxygen, water and sugar, right? So how do you write increasing? Will be the first one, will be the least, which is gas, right? What is the question? Increasing order of forces of attraction, right? So gas has the least force of attraction. So you write oxygen first. And which sign will you use? You use this sign. Okay, this sign. Then followed by the liquid state, which is water, followed by sugar. If they ask you increasing order, it's always this sign. Okay, remember that. Sugar, H2O, sugar, Vasudha, it will be oxygen, then water, then sugar. Yeah, I see you got the hang of it, most of you. This is how you write it. Okay, make sure you are writing it this way. Correct? Because they have asked you increasing order, so this is the only answer which should be there. Oxygen, water, then sugar. Okay, so we are done. Now we'll move on to exemplar. Okay, I'm going to let you do this yourself. This is easy. All the MCQs you can do it on your own after the class. Match the physical quantities to their units. Okay, you can do that also. Okay, let's do it quickly. Which of the following sets of phenomena would increase on raising the temperature? The 10th one. Write it in your books. I'll just ask one of you to answer me. So don't type, no issues. The 10th one. Which of the following set of phenomena would increase on raising the temperature? Yes, Netri, you're right. Yes, Aditya. Yes, Vasudha. You can't see the question? Okay, it's the 10th one in your workbook. Puneet, D. Why do you say D? Are you sure? Solubility increases on increasing temperature. No, Neki. Atharva is right. Ryan is right. Alina is right. So the answer to this question is the third one, evaporation, diffusion and expansion of gases. These phenomena, evaporation increases because if you increase the heat, like more particles can evaporate. That's why. Diffusion, because gases can diffuse faster at higher temperatures, right? And expansion of gases. Okay, next one. The property of flow is unique to liquids. Which of the following statements is correct? Yes. Puneet, it's the third one. Compression of gases won't increase. That's why it's the third one. Yes, Neki. You have a doubt? Tell me. What about solubility? Okay. Okay, Neki, in that question, the compressibility. So what they have done is solubility may or may not increase on raising the temperature. It depends on other factors also, right? That it may depend on other factors, but the point which they have taken here is that compression of gases definitely will not increase on raising the temperature. That will increase on raising the pressure. That's why it's the third option. By elimination, it will be the third one. Okay, 11th one. Which property? Gases and liquids behave like fluids. This one is easy, right? It's the third one again. What do you mean by expansion of gases? Okay. Compression of compression of gases is when you take let me just show you. So basically, if you have a container and suppose it's filled with gas like this, and you then put a piston here. Piston is used to compress stuff. Okay, so when you keep pushing this down, like these molecules will come a bit closer, right? So this is called compression. And the opposite of this, what happens when now the piston is here, right? So now if I'm going to, I'll just draw it here. Now when I take it back up, I'm taking it back up. So the volume occupied by the gas is again increasing, right? So this is expansion. So when you increase the temperature, what happens here? So I'll just explain it here. Okay. So when I increase the temperature, suppose this is the I'm supplying heat, okay? Heat. And so molecules will start, there is a piston here, which is controlling the movement of the gas particles. When you supply heat, they start moving with more vigorously. Their Ke increases. Okay, and automatically they will make the piston move more upwards. That's how it will result in expansion of gases. Okay. In simple words, this is why it's option 3. Because the other way around won't happen. It won't lead to compression of gases. Sorry. Okay, cleared, Abir? Okay, I think you can do these questions yourself. Then, the other MCQs. Tell me. Okay, yeah, let's take this one. The non-SI and SI units of some physical quantities are given in column A and column B respectively. Match the units belonging to the same physical quantities. Okay, so you have to match the units belonging to the same physical quantities. Here are the things. So write it in your book. I'll ask one of you. It's quite simple, isn't it? There's units for temperature. Which question? It's the 15th one. Somebody has their hand raised. Do you have any doubt? Raghav, do you have any doubt or? Okay, you want to answer? Yeah, tell me.
Can I answer?
Yes, yes, tell me.
So, ma'am, we just have to place it accordingly to the same one, right? So,
Huh,
if degree Celsius is so degree Celsius and Kelvin is for temperature, centimeter and meters for distance,
huh.
gram per centimeters cube, kilogram plus cubic meter is for weight, bar and Pascal is for pressure, and milligram and kg is for mass.
Wait. Yeah. Okay, awesome. Got it, all of you? I hope you all have written it in your books. Okay, we'll move on to the next one then. This is an interesting question. The table below shows the melting and boiling point of 4 substances. Which substance is liquid at room temperature and would rapidly evaporate if left exposed to the air? Interesting, right? Okay, first of all, check gram per cubic meter is the unit for density. Cubic meter is the units for volume. Gram is for mass. Mass by volume is density. Okay, Netri and Atharva are answering. So first we'll look at this table, right? The table below shows the melting and boiling points. If you see closely, melting point for A is -100, B is -7, C is -6, and D is 44. So what does it mean? That since if it's minus, that means at room temperature, A, B, and C are solids. If you just look at the melting point, they are liquid, sorry, right? If just looking at the melting points, we can conclude that A, B, and C are liquid at room temperature. But we move on to the boiling point, we see that A has a boiling point of -35. So which means it is vapor. Okay, so A is vapor at room temperature, B is a liquid, C is also a liquid since it has very high boiling point. And what about D? D will be a solid because its melting point is a bit above room temperature. Elena did not understand. Which part did you not understand, Elena? Which question? Okay, this question. Okay, yeah, I'm still talking you through it. Like, don't worry, I did not finish saying. I'm explaining this question. So, okay, what here you do is you look at the melting point and boiling point. What does the melting point signify? The point at which it starts turning into liquid, right? And here, okay, so, okay, I'll write it here. Okay, so room temperature is usually 37 degrees Celsius, right? What is melting point? Point at which it turns from solid to liquid, right? And what is the boiling point? Point at which it turns from liquid to gas, right? Now look at A. A has melting point of -100 and boiling point of -35, which means it's already in the gas state, correct? Ritvik, we don't need to know what is A. At 100 degree, how can gases freeze? It's just a hypothetical example, and yeah, there are certain cases. Okay, so what I'm doing is we are not going to jump to the answer directly. We analyze the table, okay, and then we decide what will be the answer. So A, from the data given, from the melting and boiling point given at 37 degrees Celsius, A will be a gas, right? Because my boiling point is way below room temperature, correct? And B will be liquid, and C will also be liquid. D will be a gas. Oh, D will be a solid, sorry. Because melting point is 44. Correct? Got this till here? Why it is gas, why it is liquid, and why it is solid. Okay. Now next question. Which substance is a liquid? Now we have our answer. Which substance is a liquid at room temperature? B and C. So the answer for the first part is B and C. Second part. Now look closely at the boiling points. Somebody has a question? I didn't understand. Okay. How is A gas? Okay, if you look at the temperature, what is a okay, Puneet, what is the melting point signify? Melting point signifies the conversion of solid to liquid, right? The point at which it's at -100. It is at -100 degrees Celsius. At -100 degrees Celsius, it melts. So I'm going to write it here. A melts at -100 degrees Celsius to become liquid, right? And at -35 degrees Celsius, it's going to vaporize to become gas. And room temperature is +37. So see this huge temperature difference here? That's why it's a gas. Am I clear now? Did you get it, Puneet? Why is A a gas? Is anybody else having a doubt why A is a gas? Okay, how did I get B and C as liquid? Okay. Okay, what I'll do is I'll explain it to you again. I'll write down everything and explain it. Okay. Uh, just keep in mind what is melting point and what is boiling point. Okay, keep these two terms in mind. Okay. So at -100 degrees Celsius, it turned from solid to liquid. At -35 degrees Celsius, it turned from liquid to gas. I'm going to write it like this. At 37 degrees Celsius, room temperature, it is a gas. Am I clear? Now B. B at -7 degrees Celsius turn from solid to liquid. Correct? And at 58 degrees Celsius it will turn from liquid to gas. So at 37 it will be 37 is less than 58, so it's still a liquid. If you are not understanding this question, write down whatever I have written. It will help you understand it. Okay? At -6 degrees Celsius, C turn from solid to liquid. And at 225, it will be will turn from liquid to gas. So 37 is way less than 225, right? So it is still a liquid. For D, what is for D? 44, it will turn from solid to liquid, and at 280, it will turn from liquid to gas, and at 37, it is still a solid. Am I clear now? Is it clear? Is it? Class will get over at 5. We started at 3, right? Okay. Anybody still having a doubt why I'm saying B and C are liquid and A is a gas? Anybody? Got it. Awesome. Okay. So now we answer the question which is there. So the question asks, the first part is, which substance is a liquid? So which is a liquid? B and C. Right? That answers our question 1. That these two are liquids. Right? And the second subpart. If you look closely at the melting boiling points for each of them, you will notice B's boiling point is 58. Okay, I'll use a different color. Right? Yeah. So 58. Right? So 58 is pretty close to 37, right? Which means B may be a sublimable solid. Okay, that's the answer to the second part. Anybody still having doubts, let me know. So which would rapidly evaporate when exposed to the air would be B, because 58 is quite close to 37. Right? Okay, so this is done. Next question. Interesting. Classify the following into osmosis or diffusion. Okay, we'll go one by one. I want your answers here. So, okay, first before that, I'll just let you know what is diffusion and what is osmosis. Diffusion is the movement of molecules from higher concentration to lower concentration, right? It's just molecules. And osmosis is the movement of water molecules from a region of high concentration to low concentration via a semi-permeable membrane. Okay, so tell me the first one. Swelling up of resin on keeping in water. Is it osmosis or diffusion? You can just write O or D is okay, fine with me. Netri, are you sure? Okay, we'll go one by one. Just tell me for the first one now. Oh, okay, yes. So easy. First one is osmosis. Second one. Okay, now we'll take the second one. Spreading of virus on sneezing.
Diffusion.
Diffusion. Okay. Yes, so second one is diffusion. Third one. Earthworm dying on coming in contact with common salt. Is it
Osmosis.
osmosis or diffusion?
Osmosis.
Osmosis, correct.
Excuse me, ma'am.
Huh? Yes, tell me.
Ma'am, you said that osmosis is the water traveling from one place to another.
Huh.
This is earthworm dying common salt, so shouldn't it be diffusion and not osmosis?
Okay, so this concept, I'll tell you how it is based on. Okay, so suppose this, just take this to be an earthworm's body, correct? Now it has water in it, right? And now I'm
Yes.
placing salt here, salt particles here next to it. Now what happens is its body will act like a semi-permeable membrane, and the water molecules, which may be less in number, but still their concentration is high inside the body of this earthworm. Correct. So what they'll do is they'll move out. Okay, and because all the water molecules move out, the earthworm will shrink and die.
So exosmosis.
Yeah, exosmosis, right?
Okay, thank you.
Okay. Anybody else had a doubt in this? No? Okay, next one. Preserving shrinking of grapes kept in thick sugar syrup. Similar principle.
Osmosis.
Osmosis.
Osmosis, correct. Osmosis, right? Next one, shrinking of preserving pickles in salt.
Osmosis.
Osmosis,
Osmosis.
right? Okay. Anybody having a doubt? Let me know. Okay, you can stop me anytime. Next one, spreading of smell of cake being baked through the house.
Diffusion.
Diffusion.
Diffusion. Okay. Uh, okay. 6 is diffusion. And the last one, aquatic animals use oxygen as dissolved.
Diffusion.
Oxygen dissolved.
Diffusion.
Okay, Atharva has a doubt. If carrot is kept in salt water for some time and it becomes weak. Okay, it's similar to the one I explained it here, Atharva. Okay, so Atharva has a question. He says that there is a carrot. Okay, a carrot kept in salt solution becomes weak. What type of osmosis is this? So what happens, Atharva, is there is water molecule inside the carrot. Okay, when you place it in salt solution, this water here travels out, comes out. If it comes out, you call it as X. So it will be X osmosis. Okay, got it? Okay, so the last one is diffusion. I hope nobody had a doubt and said nobody has a doubt in the last one, that why is it diffusion and not, why is it diffusion and not osmosis? Nobody has a doubt, right? Okay, so we move on to the next one. This are easy. Comment on the following statements is pretty straightforward. You can do that on your own. It is a hot day. Who would you think would be more comfortable? Easy. Right. Okay, this is also easy. Okay, so the remaining level 1 questions I want you all to do on your own. They are very easy. They are straightforward questions. We'll go on to level 2. You can do them after class. Right? Huh. First wala we covered. For any substance, why does the temperature remain constant during change of state? We covered this, right? Because the heat given out by the substance is used up in changing the state. You have to submit whatever I am doing today. So I am giving you like what 3 or 4 questions from level 1. Those you add to your homework and submit it, right? Whatever I am doing right now also has to be submitted. Okay. Yeah, so the first one everybody got it, right? It's simple. So why does the temperature remain constant? Because the substance which is undergoing change of state. Yeah, so undergoing change of state is the heat is used up in the change of state, right? So there will be no increase in temperature. Yes, Anirban. Arya, you are not present. Okay, so what you can do is you can do the practice. You can do the practice question 1, which is theory based, and give reasons and what happens when, and submit it. So there's a link. So what do? You do it on your notebook. Then you click pictures, use Cam Scanner or the relevant app, and convert it to PDF and upload it on the link. That's all. Okay, so there's just the additional task of taking pictures and uploading it. So the rest of the thing you're already doing, you're already solving. So you don't have to solve it again. Okay. Uh, okay, these questions seem pretty straightforward. Let me just, how much time do we have? We have more half an hour. So let me just pick up difficult ones. So level 1, do the remaining questions. Okay, level 2, whatever I'm picking up, do that. Huh. What clothes should we wear in summer? Okay, why does the water kept in earthen pot become cool during summer? Kahoot, Kahoot not today. Maybe some other revision class. I want you to. This is supposed to be a revision class, so right? Let's revise. You are doing pretty good this far, so come on, you can do these questions too. Who's willing to tell me why the third question? Why how does the water kept in an earthen pot become cool during summer? You can raise your hand. Don't need to type it all. Raise your hand. I'll ask one of you to answer. Okay, so Neki and Puneet are here. Let's say what Neki has to say. Hi Neki. So you have the answer?
Yeah, ma'am.
Tell me.
The earthen pot water becomes cooler. That one.
Yes.
Uh, 1 second, ma'am.
Okay.
Ma'am, can you hear me?
Yes, tell me.
Yeah. The earthen pot has pores, due to which it remains cool, as well as evaporation.
Okay, so how will you put them together like a sentence? Like it's not just keywords, right? You need to write it in proper words. Nikki, are you there?
Yeah.
Okay, what I'll do is I'll ask one of the others to explain. Okay. Abir, yes, tell me. Okay, so I don't know where is everybody. Okay, Puneet has also raised his hand. Let me see. Okay, Puneet, yeah, you can tell me the answer.
Hello, ma'am.
Yes.
Ma'am, the surface of the earthen pot is made up of several pores.
Okay.
So, like through the pores, the water gets evaporated, and then the pot, to regain its energy, absorbs the energy from the surroundings, which makes it cool. And also, the water inside the earthen pot gets cooled through it.
Okay, the first part I'll agree, yeah, till the point where it has pores and it gets evaporated. But the second part is that so what happens is the water gets heated up, right? And that energy is used to evaporate it. So now the water will become cooler. That's it. It won't take up energy from the surrounding or anything like that. Okay. Yeah, so you
Okay,
quite
so
got
it
it.
takes the energy from the water itself.
Yeah, so what happens is, see, it's hot. Okay, it's hot, so the pot is going to get heated, the water inside it is going to get heated, right? Everything will get heated. There's no mechanism to prevent the water from getting heated. So the water gets heated, and what happens is it tries to escape as water vapor. How does that happen? It happens through the pores, right? So now the heat is given out in terms of water vapor. So this system, there are two systems here. So this system will get cooler, right?
Okay.
Okay, what I'll do is I'll just show you with the diagram. How do you write this question? Okay, it may be easier for you to, keep this in mind instead of just remembering uh, tedious terms like that. Okay, so see, this is a pot with water in it, right? So now on a hot day, yeah, see this beautiful sun. Okay, it's going to heat up everything. So now the pot gets heated, the water inside it gets heated. Okay, and what this water is going to do, it tries to escape as vapor. Okay, so now this pot of ours, the earthen pot, has pores, small pores. I'm drawing it big so that it's visible. So the water vapor will try to escape through these pores, right? So this will be like dissipation of heat. The heat is given out from the water. The heat is moving out in the form of water vapor. So now this system, this water has given out heat, so it will become cooler, right? Am I making sense? Is this easier to understand and remember? Yes? Awesome. So don't add terms like latent heat or vaporization are not required. In this, it's just that what happens is the water is getting heated and it's trying to escape through the pores. Okay. And because of that, it's, yeah, so you can add it here by saying it tries to escape as vapor. So the heat is converted, the heat is used to change the state to vapor, and hence then you can add the latent heat part here. Okay, yeah. Then this is how you can add the latent heat part here. Yes, Elena. So the water, no, so what happens is the water converts to water vapor because of the heat. So it's not doing anything, it's converting. But in this case, the key factor here, or the main point to be mentioned here, is the pores. This is the most important word. The pores of the pot help the water vapor to escape. So this is happening in other systems as well. If you're going to keep it in a bucket, or you're keeping a water in, let's say, any other closed container which does not have pores, water is still getting heated up and it's still converting to vapor. But there is no way or chance for it to escape. That is the reason it will still remain hot. But in this case, it is escaping through the pores, hence leaving this system here cooler. This system will be cooler, and the heat is dissipated out, right? That's all. Yeah, if you want to include, like if it's a proper, if it's a 1 mark question, you can just say this much is should be fine. But if it's 2 mark, or if you need to include more keywords, yeah, you can say that the heat generated by the water is used to change the state from water to vapor, or used up as latent heat, right? The heat used to change the state will be nothing but latent heat of vaporization. Okay, got it? Simple way to remember. Don't try to buy hard things. It just gets confusing after some time. You will just be like wondering that, whether it is vaporization or fusion, or whether it is latent heat, or what should I say. So it's easier. Just keep it simple. Keep it with diagrams or ways to explain it to yourself. You don't need to draw it for the exam, but this is for your understanding, right? Okay. So that was done. Next, I want you to this question. So now I have given you all, what do you say? We have covered quite a few questions on this, and I want you to tell me this. What produces severe burns, boiling water or steam? Anybody with complete right answer, like with keywords in a proper sentence? Anybody? You can raise your hand. I'll just unmute you. You can tell me then. Who is ready to tell me the answer with all the proper keywords in form of a statement? Nobody is raising their hand. So many. Okay, I see Anirban. Let's give Anirban a chance. Hi Anirban.
That was a last question.
Oh, so okay, you don't want to answer this one. Okay. Uh, let's see, Abir. Okay, Abir, tell me.
Ma'am, yes, ma'am. Ma'am, steam produces more burns than boiling water because steam contains more heat in the form of latent heat. Hence, it hence more burns are created.
Awesome. Yeah, that's right. So it's a
Thank you, ma'am.
simple answer. Yeah. Exothermic heat. Okay, so don't use these hi-fi words like kinetic energy, exothermic, and all that, because if you don't really understand the meaning of it, okay, it won't be. See, heat is never exothermic. Heat is like always exothermic. Like how do I say you? Uh, Exothermic and endothermic are ways of representing what happens to the heat, right? So don't mix it up here. Just keep it in simple terms. What produces more severe burns? Steam. Like Abir said, his answer was awesome, great, yeah, everything. Why steam produces more severe burns? So first part we answer what produces. It will be steam. Why does it produce more severe burns? Because the boiling water, the heat generated by boiling water, okay, is used up in uh you know in the change of phase to steam, or is used up as latent heat of vaporization. Just you write that one word, right? Puneet, you need to submit whatever I'm doing now also, so include these questions which I'm taking up, not the others, just these ones. Level 1 all questions, level 2 which I'm taking. Yes, Neki, you're right. It has more latent heat of vaporization or evaporation. Yeah. Hence, it produces more burns. Easy. Okay, others are pretty straightforward concept questions. Yeah, this one is nice. Look at the following figures and suggest in which of these vessels A, B, C, or D the rate of evaporation will be the highest. Mansi, this question was 1.2.6, and now I want you to answer 1.2.10. Look at the following figures Abir, are you sure? Okay, again, anybody ready to answer? You can raise your hand. Okay, let's see. Okay, Ryan has an answer. Okay, let's Ryan answer this time.
Ma'am,
Yes.
ma'am, in vessel 8, there will be more evaporation.
In A, why?
As there is more surface area.
Why not B and C then?
B and C have less surface area than A.
Okay, what about the other factors?
Uh, but in C, there will more than A as there is fan above.
So fan is also there, correct? Then what are the factors we need to consider?
More surface area.
Hmm. More surface area, wind speed. Then I think there are two more, right? Okay, it will be humidity and temperature. So there are four factors affecting evaporation, which is basically humidity, temperature, surface area, and wind speed. Right? Okay, let me see. There are some few people more who want to answer. No. Okay. So if you look closely, okay, yeah, you can say A has more surface area. That's the highest amount of surface area compared to B and C. C and D look similar in terms of surface area, and B has the least. Right? If it was just surface area, A would be the A would be the highest, right? But now we have to consider the fact that D has a lid on it. So D is like completely out of the question. There will be no evaporation occurring. Now we consider the fan. The fan is directly above C. So what happens is, as the particles of C evaporate, this fan is going to, spread them out in the air and create a zone where, it can evaporate more. It will increase the wind speed. Because of the wind speed, evaporation of C will increase. So because it has, even though it looks like it has a bit less surface area than A, the highest evaporation will be from C, followed by A and B. Yeah, A will be the least because it's far away from the fan. So yes, because of surface area, evaporation will occur, but it will be not that fast. Got it? Anybody who did not get this question, let me know. Yeah, D will be the least. Correct, Puneet. So they have just asked you which the rate will be the highest. So it will be C. Okay, got it. Why? Because of the fan and the surface area. 2 points. Ensure to mention that. Okay, what else? These are easy questions. Dissolved in sugar. Yeah, okay, this one. This is also easy. Let me see. A student dissolved some sugar in water. There is hardly an increase in volume. What is the characteristic of matter illustrated in the observation? Very simple. We did this already. Okay, Puneet has a doubt. Yeah, Neki, you answer this, then we'll go back to the question Puneet has a doubt in. Yes, Neki, tell me.
Ma'am,
Huh.
there is hardly an increase in volume because there is intermolecular spaces between the molecules of water, so
Yes.
sugar will be diffused evenly and settle in those spaces, so there will be not not more volume change.
Awesome. That's right. Awesome. Yeah. So what Neki said is right. So the sugar matter has spaces in them. Yes, that is the characteristic which is observed, and the sugar molecules will go and occupy those spaces. Right. Okay, Puneet had a question in what is bromine. Okay, bromine is like a, what should I say, a solvent. It's brown in color. Okay, and it fumes. So yeah, it's a chemical. I don't know how should I explain it to you. It's a brown colored solvent is what I can say. Yeah, Puneet, but that does not have any relevance to the question asked, right? So yeah, you can solve it without knowing exactly what bromine is. It's just a liquid solvent which is used to give color mostly in chemical experiments. Okay, so yeah, we'll which should I take now? Choose the, yeah, let me see. Seema visited a natural gas compressing unit and found that the gas can be liquefied under specific conditions of temperature and pressure. While sharing her experience with her friend, she got confused. Help her to identify the correct set of questions. It's a direct, straightforward question. Let me see who gets this. You can just write in your option number. That will be fine. Okay. Okay, so I'm getting answers. Yes. The third one, yes, you all are right. You got it. It's very easy, right? Straightforward. Okay, yes, the next one is also you can solve it. It's just plain conversion to Kelvin scale. You just add 273 Celsius to Kelvin, so you will add. Okay, you add. What about the next one? Option 3, yes. Arav. Okay, y'all have done the question also. Nice. So you got the options. Okay, yeah, you can do this 1.2.6 also converted from degree to Kelvin. Add 273. That's it. Okay. Hmm. Okay, we'll just do this the last 2-3 questions, then we'll stop. Okay. Yeah, we'll not go to level 3. Option D. Anirban, are you sure? Check your calculation once. So the 18th one is simple, right? You just have to add 273, right? Okay. So the answer will be the third one. Yes, okay. Okay, which condition out of the following will increase the evaporation of water? When I increase the temperature, decrease the temperature. This is also straightforward, right? First option, yes. Yes, Elena, Tanisha, Ryan, yes. Anirban, yes. Mansi, yes. It's the first one. Which of the following conditions will increase evaporation of water? It's increase in temperature of water. Yes. Because when you increase the temperature, how is this explained? It will be when you increase the temperature, the molecules start vibrating with more energy. They start moving in their places, and soon at a point, the boiling point is reached, and they will start converting to vapor and evaporate. Till the boiling point is reached, they start moving with increased kinetic energy. So here you can use the term kinetic energy. Correct? Okay. Yes, Shivesh. Next one. Next is interesting. Which of the following conditions the distance between molecules of hydrogen would increase? So what are they asking you? They are giving you a set of conditions and they are telling you which of them the distance between the molecules of hydrogen gas. So what is it? I'll just show you. So there is a container. Okay, there are hydrogen molecules. So now they are asking you under what conditions the space will increase. It will become like this. Okay, yeah. What are the conditions they have said? Increase pressure on hydrogen in a closed container and some hydrogen gas leaking out of the container, increase the volume of the container or add more hydrogen gas. So two of them are correct. So yes, Neki, you're right. Yeah, that's the right answer. Oh, just a second, my screen. Huh. Shivesh, what is the plus plus? I don't know what are you trying to say. 1.2.20. Yes, Elena has answered. Yes, Elena, you're right. What about the rest of you? What happened? You did not understand the question. I'm not getting any response. Only two of you answered. Three of you answered. Okay, Tanisha and Puneet have also answered. What about the rest? What happened? Atharva, okay. Ritvik, yes. Which question? The 20th one, Riya. Which of the following conditions the distance between the molecules of hydrogen gas would increase? So if you increase the pressure on hydrogen contained in a closed container, what will happen? The distance will decrease, right? They'll come closer. The gas is ideally getting compressed, right? So that's not the case. Then some hydrogen gas leaking out of the container. If it leaks out, what happens? The molecules get the chance. The remaining molecules in the container get chance to occupy the rest of the space, right? And so that can be one option. And increasing the volume of the container of hydrogen gas, yes. So yeah, Arav has answered, Riya has answered, yes. So if you increase the volume of the container, what happens? Okay, I'll just show it to you here. So the first part is what? First part is what are we doing? Increasing the pressure of hydrogen, right? If I'm increasing the pressure, what am I doing? These are the molecules, right? This is how you use a piston to exert pressure. I'm exerting. So what will happen? They'll come closer. They'll come closer as I exert more pressure. So this is out. What is the second one? Second one is saying some escape out, which means yeah, the remaining have more space, right? So this can be considered as an option. The third one being increase the volume of the container, right? So the container is this big, has 3. I change it to this big, so it has ample space to move, right? And what is the last one? Adding more hydrogen gas. Adding more hydrogen gas to the container without increasing. So earlier it was what say, oops, okay, and it was like 3, right? And now I added more hydrogen gas without increasing the container. So obviously this is also not an answer, right? That's how it's the option C, 2 and 3. Yes. Okay, next one. Next one is easy. Alka was making tea in a kettle. Suddenly she felt intense heat from the puff of steam gushing out from the spout of the kettle. She wondered whether temperature of the steam was higher or that of the boiling water in the kettle. Come on, all of you are going to write this in your notebooks. This we've discussed many times now. I think you will know what's the answer, right? So it's because the steam the steam has taken up all the latent heat of vaporization. Ensure latent heat of vaporization. You're writing that. So write the answer. Okay. Once you've written it down, we'll do the last question, which is osmosis is a special kind of diffusion. Okay, I want to do one more question after this. Okay, the Alka one, you all can write it down afterwards. Let me just finish this. Osmosis is a special kind of diffusion. Comment. Anybody up for it? You can raise your hand. Yes, Puneet. So, yeah, Abir is up for it. Okay, Elena. Nice. I would like to hear Elena's voice. Yes, Elena, tell me.
Ma'am, can you hear me?
Yes.
Ma'am, the definition of osmosis is the transfer of the solvent from higher concentration to lower concentration through a semi-permeable membrane,
Yes.
while diffusion is just the transfer from higher concentration to lower concentration.
Correct.
So osmosis could be a special kind of diffusion because it just requires a semi-permeable membrane. Otherwise, it is kind of similar to diffusion.
Yeah, you're right. That's good. Awesome. You said the right answer. Okay, so basically, yeah. So in diffusion, it's just molecules moving from higher concentration to lower concentration, whereas in osmosis, it's water molecules, right? Specific water molecules. So it is a kind of diffusion. The same thing happens, but it moves across a semi-permeable membrane, right? Okay, I hope no doubts in that. Everybody can answer this, right? I want you to write it down. Osmosis is a special kind of diffusion. The answer, I want it in your books. Not here, but in your books. Okay. And I want to do just one question. Yeah, this one. The last question for the day. I know it's from miscellaneous, but it's an important one. I'm surprised why it's not there under NCRT because they do ask this question. Okay, the question is, why is it advisable to use pressure cooker at higher altitudes for cooking food? Anybody can answer this question? We covered this, I think, in the beginning of this class. I covered this concept. The question is, why is it advisable to use pressure cooker at higher altitudes for cooking food? You can raise your hand or you can type. Anything is fine. Yes, Puneet, halfway there. Come on, come on. I'm okay. Neki has raised her hand and Abid. I want somebody else to answer. Anybody else? Ria can answer. Yeah. Okay, Abir. Yeah, you can answer. Hello, Abir?
Ma'am, can you hear me?
Yes.
Ma'am, at higher altitudes, the atmospheric pressure is low and the water boils very fast,
Okay.
and obviously the evaporation rates get fast. So, ma'am, the pressure is required to increase.
Huh? Pressure is required to increase what?
Ma'am, we have to increase the pressure so that so that the water does not boil fast easily.
Acha. Okay, you are saying pressure cooker is used for that.
Yes, ma'am.
Okay. Yeah, yeah. Okay, that's right. Okay. So Abir has given us the right answer. We covered this in the class, right? Initial this stages, that what is the definition of boiling point? I think we started with this, right? Boiling point is the point where the vapor pressure equals the atmospheric pressure. So at higher altitudes, as you go high, the atmospheric pressure comes down, right? Oh my god, Vasudha has typed in the whole thing. At higher altitudes, atmospheric pressure is less than the place near the sea. Yes, this causes water to boil at a low temperature. Yes, and hence take food longer time to cook. Correct. The pressure cooker prevents this and leads to quicker. Awesome, Vasudha, awesome. Right? So that's it. So first, how do you understand this question without, without just directly by hearting it? What happens? At higher altitudes, the pressure is low, right? What is boiling point? Point at which the vapor pressure equals the atmospheric pressure. Now the atmospheric pressure itself is low, hence the vapor pressure required to equal that will be low. So water will boil not at 100 but less than that, right? Because of this, the food will not cook properly. It will not cook, um, and as it should. It will boil faster. The water will evaporate out of the food, leaving it, raw or half cooked. So what do? You use pressure cooker at high altitudes. Okay. If they ask anything about high altitudes, first point, the most important point you mention is atmospheric pressure is low. Okay. Yeah. That is a crucial point you are going to add about any questions about altitude at higher altitudes. Okay. Yeah. So what homework do I want from you for today? Is you're going to complete, all those of you who have not completed practice questions 1, so you need to do the theory based questions, what happens when and give reasons. Okay, those of you who've submitted, I'm going to check. Okay, so it's not like you are going to get away with it. I will be checking. I'm giving you time till tonight you can submit all this. Okay, all those who had submitted the previous, what happens when the practice says questions and all, you can directly submit all questions of level 1 and level 2. Level 1 and level 2 only NCERT and exemplar. Okay, no need to do miscellaneous. So level 1 we covered almost quite most of them. I think only 2 3 are left. Even in level 2 only 2 3 are left. So do those questions as homework, and the rest whatever I did in class should be there. Proper statements, proper key points, everything. Okay, that's it. Homework. Okay, we'll end the session then. You can leave. All level 1 and level 2. Yes. NCERT and exemplar only. No miscellaneous. Okay. Yes. Last date today, tonight. I want it by tonight since we covered most of it in class, and that was the previous homework which you were supposed to do, right? So tonight. Okay, tonight I'm going to be telling, there will be a list put up who has not submitted tomorrow otherwise. So tomorrow you'll be given more homework. You'll just pile on. Try to submit it by tonight. Okay, we did most of the questions in class, right? Only 2 3 left. Okay, bye guys. Try to do it by tonight. Otherwise it will just pile up. Bye bye.